Hi, welcome back to Geology. I'm Miss Sparks. I want to go ahead and start kind of getting into some of the nitty-gritty of the things that we will be talking about in this class because it's just, once again, one of my favorite topics to talk about. Hopefully I can share my passion on through to you guys, just learning about the different processes, and we'll talk about different things that are happening in current events that kind of relate to things that we'll be kind of going over today and the rest of the semester. So things that that are happening that we can kind of even relate to today are the wildfires that are happening out in California, which are brought on by atmospheric pressure that they are having extreme amount of lightning strikes, and we'll talk a little bit about that. There's also a little bit of a drought in the area, and that's been happening for several years. That's not just a occurrence of 2020. The Pacific side of the United States has really been plagued by several years of drought. We'll also talk about things that have happened more recently, earthquakes. There was a freak earthquake that happened over the summer in North Carolina that doesn't always happen, but we are prone to earthquakes in this area. Cincinnati and northern Kentucky and Indiana, actually, we sit on a fault line. It's not very active, but it does have the ability to create an earthquake in our area. And then we'll also talk about things such as like the double hurricane that is coming through the Gulf of Mexico. So these are all things that we can kind of relate back to this class somehow, some way, some form, and try to figure out why are these happening, or is there a cause or a rhyme or a reason? And the answer is there is. So in order to understand all that stuff, we have to kind of understand the earth in just its glory of all the different moving parts that kind of go along with it. And that's what we're going to be discussing today. So these are notes. So please make sure that you get out a sheet of paper, get down what's underlined or what I'm kind of pointing out. These are going to be really helpful for when we get to tests and quizzes, and then at the end of the term, the actual final. So don't let yourself fall behind and not take these notes, and then when we get to the end of the unit or something, you're like, I don't have anything tangible. So make sure you are doing that just a little bit. Don't cut yourself short there. So let's move on to slide 2. So all right, so studying the earth, once again with my notes, just get down the things that are underlined or what I'm kind of pointing out here. And so these are the branches that we are going to be talking about. So a lot of times students will get into this class and be like, we're just going to be studying rocks, right? And I'm like, yeah, that's a portion of it, but there's way more to it than just that. And so as you can see, we're going to be talking about all these different branches. So geology is the main one, and we will spend quite a bit of time. And once again, that is my passion. I'm a geologist, a trained geologist at heart. That's my bachelor's of science. My undergrad is in geology, and I actually worked in the field for a little bit of time too. So I am a trained geologist, but we'll also talk about oceanography. So the study of the complexness of the ocean and all of its different parts, such as trenches and the seafloor and the shorelines, and then even some of the life that's happening there, and the water that is in the ocean too actually is very significant. And we'll talk about things that are kind of happening with the water there as well. We will connect oceanology or oceanography to climatology as well. So we'll start talking about things that are happening, weather patterns and long-term weather patterns versus short-term weather patterns. What are things that are happening? Sometimes we can look at things that happened in the past to help us figure out maybe what's happening right now or in the future, and we'll talk about what that actually looks like. There will be a little bit of astronomy. I can't let astronomy fall aside. There are a lot of planets that are actually rock-based, our inner planets. So Mars, Mercury, Venus, and Earth are all rocky planets which have geologic features to it. Venus and Mars are the two. Earth sits in between those two planets, and we actually know quite a bit of geology about the two. Exciting things happening is that we're really close to actually sending people to Mars. SpaceX, one of the companies that has been launching several rockets into space, recently just sent 2 individuals out into space, successfully docked with the International Space Station, and then returned back. That's their next goal, is a mission to Mars. It was 2020. I don't know if they've pushed it back at all, but that was their goal, is this year go to Mars. And then finally, we'll kind of connect everything with environmental science, because we have to look at plants and animals that are also being affected by these, especially these first three: geology, oceanography, and climatology. So these are our different branches that we're going to kind of talk about. So the biggest thing that we're going to be looking at is just making observations and looking at how things are laid in the rocks, or how they look to us, and then go back and figure out, well, what kind of environment did this have to be in order for it to form the way that it is. So natural forces that shape and affect the life on Earth. So for example, if you think about, if you were to go outside and I asked you to go find a rock, you might find one that looks like it has a shell in it, and you might be looking around like, I do not live on beachfront property. How is this possible? So then we have to put clues back. Well, if that is a fossilized rock that had a shell in it, more than likely at one point this area had to be much more of a coastal region, and it was. We were actually a shallow sea many moons ago, and we'll talk about what that looks like. So forces are going to affect different things, and we'll even talk about plate tectonics with the forces that are occurring there, and what do we expect to see in some regions in maybe 1 million years or 2 million years. What's that going to look like versus what it is today? There are things that are completely changing the landscape of different continents as we speak. It's a slow process, but it is a process. The scientific method, we'll use this quite a bit, so I'm just going to kind of brush over it really quickly. So we are going to be looking at using our CER, or claim, evidence, and reason, to kind of connect it to the scientific method, where we'll come up with a hypothesis, we'll make some observations, collect data, and then make a conclusion. And then some things are going to be retested over and over again, where we may come up with the same conclusion, or it could be retested and it kind of shapes out a little bit differently every time, and that's going to affect how we think about things too. So we will use the scientific method. You'll hear me say the 3 terms, and most of you that have had me before know my claim, evidence, and reason. We'll use these quite a bit to kind of look at different types of features. And so one thing that we will be talking about is just accuracy and precision, which is just making sure that we are being really precise, because there are a lot of things that we are going to be talking about in this class that are going to be on super large scales. We can talk about eras, so like the Jurassic era or the Triassic era. Those are huge pieces of information that we kind of have to look at. So sometimes we have to look at how we're measuring things. So accuracy is how close a measurement is to the value of the thing being measured. So we want to be as accurate as possible. And precise is the exactness of the measurement. So we're going to use the 2 terms qualitative and quantitative to kind of help us with this, and we'll move into that in just a little bit. So these are terms that you're probably very familiar with, theory and law. So we will use these quite a bit. We will use scientific laws such as Newton's laws of motion, using speed and acceleration to help us figure out how things might be moving. We will talk a lot about pressure and the amount of force and work that is being done on objects to help us with some theories. There's going to be a lot of theories in this class. So continental drift, Pangea, we'll talk about natural selection and how things have kind of moved on from one environment to the next. And then we'll even get into talking about, well, how the heck did the Earth even get here, which then kind of incorporates the Big Bang Theory and the theory of planetary nebulas and all kinds of different things. So we can use concrete information, laws, and math to help us kind of decipher some of these theories that we're going to kind of go over. So kind of just jumping into some things that hopefully you are familiar with, and we're going to spend a lot of time talking about this, but just kind of briefly introducing it to you, is that there's two different types of ways we will look at the Earth. The physical layer, which is consistent of the crust, mantle, and core. So crust is the outermost layer, mantle, and then the core is the innermost layer. I like to call these baby terms. We're not going to use those too much anymore. I want to move into the chemical layers, which breaks down different types of forces and temperatures and pressures that we can really get into the nitty-gritty of things that are happening here. So our chemical layers is the lithosphere, which is the outermost layer, the crust, but now we're using the term lithosphere, the ozonosphere, which is the upper part of the mantle, and the ionosphere is doing something really important that we'll discuss. The mesosphere, the outer core, and my picture's off a little bit, the inner core. So some of them kind of do connect, but as you can see, we've kind of beefed up the crust and mantle by talking about what is actually happening there. So there's different types of temperatures and different types of pressures that can cause different types of chemical reactions. And that is where we're really going to focus in on what's going on in these two different models. So just kind of once again give you a little bit of an example. The main body of the Earth is our crust, and then if we think about the core is made mostly up of iron and magnesium. These are heavy elements that have sunk to the center of the Earth, and they're doing something really important, and we'll discuss that. You probably already know what it is, but if you think about it, it's causing a turning process, and if you've had me in integrated, hopefully you remember the term convection. It's convecting. Heat rises, cools, and sinks. Heat rises, cools, and sinks, and that's exactly what this is doing. Kind of just breaking down the chemical layers just a little bit more. So lithosphere outer, the ionosphere is 2/3 of melted plastic, meaning that it is rock that is heated up ever so slightly that it kind of flows. So think about, I always think of the idea of if let's say that you're at home and you have some leftover macaroni and cheese that you're going to heat up in the microwave. So it's in a Tupperware plastic container. You put it in the microwave and you accidentally hit 3 minutes instead of 2 minutes. And you pull it out and the tub kind of bends just a little bit. It's not as firm as it was before you put it into the microwave. This is kind of how the rocks are moving in the ionosphere. So they have just enough pressure that they're going to flow a little bit, and we'll really talk about that process as we move forward in the next couple of days. The mesosphere is actually a total solid layer. The outer core is liquid and it's convecting, heat rising, cooling, sink, rising, cooling, sink. And then the inner core is totally solid. So the chemical layer actually goes solid, liquid, solid, liquid, solid. It alternates back and forth, and that's going to be really important as we move through. So just to give you a couple of things here, whoops, sorry. There we go. Lithosphere, once again, you can see that it's the thickness that kind of varies. There are 3 different types of rock layers or rock types that we can find in the lithosphere: our igneous, our sedimentary, and our metamorphic. Those are terms that you've probably heard of before. We will spend a great deal of time of talking about them. Hopefully we'll be in class and I can show you examples of them and how we can decipher between one and the other. But igneous is pretty much cooled magma. Sedimentary is weathered rocks that are recompacted and cemented together. And then our metamorphic rocks have been heated and then put under some type of pressure to cause a crystallization of transformation of some sort. The hydrosphere is our oceans and lakes. 70% is covered in water. Hydrosphere is salt, less of it is fresh water. And then finally our atmosphere, which we'll talk quite a bit about, is our gas layers that kind of envelope around the Earth. So these are kind of the things that we'll discuss as we move through, just kind of a quick introduction. You'll probably want to make sure that you have some of these things down. I almost forgot the biosphere. I'm running out of time, so I'm squeezing it in. This is going to be our life, what is connected to the rocks and everything around it.